Hi all. In the previous class we discussed about Ampere's circuital law. Ampere's circuital law used to find what is Ampere's circuital law used to find H bar. H bar, that is magnetic field intensity, or B bar. Both we can use Ampere's circuital law. Ampere's circuital law states that the line integral of H dot dl, the line integral of magnetic field intensity over the length dl, that is closed line integral H dot dl equal to closed line integral H dot dl equal to I current enclosed by that path. This is also known as Ampere's work law also we discussed previously. The path enclosing direct current is need not to be a circular. A circular, not only the current need not to be a circular, but it may be infinite long conductor or straight conductor, or the law does not depends on the shape of the path. But the path must be enclosed the direct current once. This path selected as Amperean path. Ampere's circuital law, if you apply, it is known as Amperean path. Similar to Gaussian surface in the previous Gauss law, that is electrostatics, the surface over which we applied the Gauss law is called Gaussian surface, whereas if you apply the Ampere's circuital law, that surface, that path is known as Amperean path, similar to Gaussian surface used while applying Gauss law. Now we go for what are the steps to be followed for Ampere's circuital law to apply anywhere, and some examples, what are the applications of Ampere's circuital law. Let us solve. The following steps to be applied while applying Ampere's circuital law. What are the steps to be followed for applying Ampere's circuital law? Let us go for that. Steps to be followed. Step 1 is consider a closed path, preferably symmetrical, such that it encloses the direct current. We have to consider a closed path, preferably closed path we have to consider. Closed path. Consider a closed path, preferably symmetrical such a way that it encloses the direct current once it encloses the current I. We have to consider any closed path that currently carries the current, because current will flow only in closed path, not in open path. We have to consider that encloses the direct current I once. This path is known as Amperean path. Amperean path it is. Now second step is consider differential element dl, differential length dl depending upon coordinate system. If you use Cartesian coordinate system, dl equal to dx in x direction, y equal to dz in z direction. That is, consider differential length dl depending upon the coordinate system used. Identify the symmetry, and step 3 is identify the symmetry and find in which direction H bar exists, in which direction H bar is moving. We have to identify the symmetry and find the direction of H bar exists according to the coordinate system used. That is, first we have to consider closed path, after that we have to consider differential element, different coordinate systems we can use, Cartesian, cylindrical, spherical, mostly we are using this, and identify the symmetry in which direction it is moving, and find direction of H bar according to the coordinate system we are using. The fourth step is the law we are applying. Find H dot dl. Find H dot dl, the dot product. Make sure that dl and h are in same direction. Suppose dl in x z direction, it is dz, but if H bar is in dx direction, ax direction, if it is ax direction, if H bar is, make sure that dl and H bar both in same direction, then only dl equal to dz az in case of z axis direction. If H bar, if you consider in x direction, then ax will come, unit vector. Ax dot az is not equal to 1. Hence we have to consider dot product of ax dot ax is 1. Hence both we have to consider in the same direction. Okay, again we will see what are the steps in Telugu. Closed path we have to consider. the closed path only we have to consider for applying the Ampere circuital law. Closed path మాత్రమే తీసుకోవాలి. ఓపెన్ పాత్లో కరెంట్ పోదు కదా. సెకండ్ స్టెప్ వచ్చి కన్సిడర్ డిఫరెన్షియల్ ఎలిమెంట్. ఒక డిఫరెన్షియల్ ఎలిమెంట్ తీసుకోవాలి, అది ఏ కోఆర్డినేట్ సిస్టమ్ అయినా వాడచ్చు. సపోజ్ జెడ్ యాక్సిస్ కార్టీషియన్ కోఆర్డినేట్ సిస్టమ్ పడితే డిఎల్ ఈక్వల్ టు డిజెడ్ అవుతుంది. నెక్స్ట్ కన్సిడర్ ఐడెంటిఫై ద సిమెట్రీ అండ్ ఫైండ్ హెచ్ బార్ ఎగ్జిస్ట్ ఇన్ అకార్డింగ్ టు ద కోఆర్డినేట్ సిస్టమ్ యూజ్డ్. హెచ్ బార్ డైరెక్షన్ కూడా మనం కనుక్కోవాలి. హెచ్ బార్ డైరెక్షన్ ఒక డైరెక్షన్లో ఉందనుకోవాలి. డిఎల్ డిజెడ్ అనుకున్నాం కదా, డిఎల్ ఏ డైరెక్షన్లో ఉందో హెచ్ బార్ కూడా అదే డైరెక్షన్లో ఉంటే చూసుకోవాలి. ఎందుకంటే డాట్ ప్రోడక్ట్ ఆఫ్ ఏఎక్స్ డాట్ ఏఎక్స్ ఈక్వల్ టు 1 కదా. కాబట్టి మనం హెచ్ డిఎల్ రెండు డైరెక్షన్స్ యూనిట్ వెక్టర్స్, ఇవి డైరెక్షన్ ఇండికేట్ చేయడానికి వాడతాం కదా. అంటే హెచ్ డాట్ డిఎల్ ఏఎక్స్ డాట్ ఏఎక్స్ ఈక్వల్ టు 1 అవుతుంది. కాబట్టి మనం రెండు హెచ్ అండ్ డిఎల్ బోత్ ఆర్ ఇన్ సేమ్ డైరెక్షన్లో చూసుకోవాలి. నెక్స్ట్ ఫైనలీ వీఆర్ అప్లయింగ్ ఇంటిగ్రల్. దట్ స్టెప్ 5 ఈస్ అప్లై ద ఇంటిగ్రల్ హెచ్ డాట్ డిఎల్. Apply the integral h dot dl around the closed path assumed and equate it to current. H dot dl equal to current. H dot dl equal to current, or equate it into current. H dot dl equal to I. In this, these are the steps to be followed for applying Ampere's circuital law. Solving this for h bar, we get required magnetic field intensity due to the direction of current. To apply Ampere's circuital law, the following conditions must be satisfied. What are the conditions? You have to see the conditions. To apply Ampere's circuital law, the H is either tangential or normal to the path. First is the H bar. The H bar, what are the conditions? Let us see. One of the condition is H bar should be tangential or normal to the path at each point of the closed path. Already we know that the tangential H bar will be always in tangential to the path or normal to the path. Second one is the magnitude of H bar. The magnitude of H bar must be same at all points of the point where H is tangential. These are the 2 points we have to apply. H bar is must be same at all points. H bar is constant. If you consider a surface area, H bar means magnetic field intensity is constant. We have to assume. These are the some steps and conditions required for applying Ampere's circuital law. Now we go for applications of Ampere's circuital law. One of the application is H bar, but different conductors, long straight conductors. The applications of Ampere's circuital law, let us go for that. The applications of Ampere's circuital law. One of the application is H bar due to long straight conductor, infinitely long straight conductor and finitely long straight conductor. Infinitely long and finitely long. Previously we applied Diosavas law to find H bar. Similarly, we are applying Ampere's circuital law to find H bar. H bar due to finitely long straight conductor, we will see now. Let us study the various cases and applications of Ampere's circuital law to obtain H bar. The Ampere's circuital law almostly we are using for to obtain H bar only. Due to infinitely long straight conductor and infinite and finite long straight conductors, we can apply the Ampere's circuital law. Now it is the first application is H bar due to infinitely long straight conductor. Consider infinite long straight conductor placed along z axis. Previously how we obtained the same principle we are applying, but we are applying Diosavas law previously. Now we are applying Ampere's circuital law. Consider a long straight conductor. Consider the long straight conductor. It is along z axis. It is along z axis. The straight conductor is. Assume that XYZ coordinate system or whatever this, we can apply different coordinate systems. Consider an infinitely, okay, the conductor is here, we can see the conductor. The conductor is carried out along z-axis. It is x-axis, it is y-axis and z-axis. The conductor is placed along z-axis. Assume that it is a conductor. The conductor carries a current I. A current I is flowing in this conductor. It is along z-axis. Consider the Amperean closed path. Due to this current, a magnetic field will be produced that will be considered as Amperean closed path. Consider an Amperean closed path. We have to consider. The second step is consider an Amperean closed path enclosing the conductor. Enclosing the conductor. ఈ కండక్టర్ చుట్టూ ఒక క్లోజ్డ్ పాత్ అనుకుంటున్నాం. దట్ ఈస్ కాల్డ్ as Amperean closed path enclosing the conductor. Now consider a point P on the closed path. A point P, assume that it is the point P. A point P, you assume here a point P is located on the closed path at which h bar to be obtained. Where we have to calculate h bar? ఇక్కడ h bar కనుక్కోవాలి. h bar ఇక్కడ కనుక్కోవాలి కాబట్టి we are assuming that it is a point P and dl also. We can consider dl bar or dl. The radius of the path is r. From the origin, the radius of the path r, it is r. And hence P at a perpendicular distance r from the conductor. Because it's a radius, it is also radius. The point P is located here. That is also radius. The magnitude of h bar depends on the radius r and the direction is always tangential to the closed path. That is another step we followed is the direction is always tangential. It is a phi direction. Assume that. Spherical coordinate system, if you consider a phi direction, it is the origin. It is the origin. The closed path you may be considered as this is the closed path. Amperean path. ఏదో ఒక పాత్ అనుకోవాలి, క్లోజ్డ్ పాత్ అయి ఉండాలి అది. The magnitude of h bar depends on r మీద డిపెండ్ అయి ఉంటుంది and always tangential to the closed path. That is a phi we assume. So h has only one component. H bar is in this direction. H bar is in this direction. H has only one component in a phi direction, that is h phi. We can write h bar equal to h phi a phi. We can write because a phi direction it is. Second step emundi, we have to consider a differential length dl also differential length we are assuming here. Assume that a differential length of the closed path is dl we assumed at point P. At point P దగ్గరే మనం dl కూడా తీసుకుంటున్నాం. అప్పుడు dl in spherical coordinate system dl equal to r d phi a phi. We can write r d phi a phi. R d phi a phi, that is dl. Now we are applying find h dot dl. To find h dot dl, let us see. Now therefore according to Ampere's circuital law, first we have to find dot product of h dot dl. H and dl dot product. Therefore h dot dl equal to h dot dl, if you apply h dot dl, that equal to, already we assume that h is h phi a phi direction dot r dl we assume dr d phi a phi. Or d phi a phi we can write, or d phi a phi we can write. Now a phi dot a phi becomes 1, hence we are multiplying a phi dot dot product of a phi and a phi is 1. You can write a phi and a phi dot product is 1, hence we can write h phi a phi dot a phi is 1. See, this becomes 1. We can write h phi or d phi. That is the dot product of h dot dl. Now according to Ampere's circuital law, what is the Ampere's circuital law? In any closed path, h dot dl equal to I. Current enclosed. Now in spherical coordinate system the limits are phi equal to 0 to 2 pi. Pi equal to 0 to 2 pi. Therefore, according to Ampere's circuital law, we applied this one. According to Ampere's circuital law, we applied. Now, therefore, if you apply the limits, phi equal to 0 to 2 pi. 0 to 2 pi. After that, what we are finding? We are applying h dot dl. H dot dl value already we calculated. H phi r d phi equal to I. We written like this. Now h phi r we have to integrate with respect to d phi. Hence we can h phi r integration యువతలకు తీసుకొచ్చాం అనుకోండి left side, that is therefore we can write h phi into r phi equal to 0 to 2 pi d phi. We can write 2 pi d phi. We can write like this, equal to I, that is equal to I. Now integration of d phi is phi. If you apply the limit phi equal to 0 to 2 phi, then what you will get? H phi r into integration of d phi is phi and limits are 0 to 2 pi, that equal to I. Understand this. Now h phi into r, apply the limits. H phi into r, apply the limits. H phi into r, apply the limits. 2 phi upper limit we applied and 0, that equal to I. Finally we will get only 2 pi. Therefore h phi equal to h phi into r into 2 pi equal to I. H phi into r into 2 pi equal to I we obtain. Therefore from this equation h phi equal to, we can write h phi equal to I by 2 pi r. I by 2 pi r, that is h bar. H phi in direction of phi direction, h phi equal to I by 2 pi r, that we obtain. H phi equal to I by 2 pi r. Hence h bar at any point, at a point P is given by h phi a phi equal to I by 2 pi r a phi we can write. Therefore we can write, therefore h bar equal to, we know the already we assume that h phi a phi, h bar equal to h phi a phi. What we assumed previously, we assumed that h bar equal to h phi a phi we assume. Now we can write h bar equal to h phi a phi. Hence h bar at point P is h phi a phi. In place of h phi we can substitute I by 2 pi r a phi. I by 2 pi r a phi we can substitute. I by 2 pi r a phi, that is amperes per meter. By this way we can calculate, we can find h bar due to infinitely long straight conductor by using Ampere's circuital law. Next we go for another application, h bar due to coaxial cable, h bar due to different conditions, h bar due to different surface charge densities, h bar due to infinite sheet of charge, different applications. Why, how we applied Gauss law? Similar way we can calculate h bar due to coaxial cable. We applied h bar due to Biot-Savart's law, we applied h bar due to coaxial cable. The same answer. Previously what you calculate h bar, same answer you will get. Previously Biot-Savart's law you applied, then you got the answer I by 2 pi r. But direction may be different, h bar. According to our requirement, we have to consider. Next we go for h bar due to coaxial cable.